Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about calculation of physical address. Now, we need to see about different procedures required to calculate the physical address, and also we will explain the procedures by considering some example problems. So here, first, before going to the procedures of calculating the physical address, we need to know first what is meant by physical address. Okay. So here, physical address is the address where actually the operand is resided. Generally, in order to calculate this physical address, we require segment address and offset address. Okay. So here, to calculate the physical address, segment address and offset address is required. Now, here generally, segment address will be coming from any of the segment registers. So, in 8086 microprocessor, in the register organization, we have seen that there are 4 segment registers available. They are code segment, stack segment, data segment, and extra segment. All these are 16-bit registers. So from any of these segment registers, we can get the segment address. And next one is offset address. As we have seen in the register organization, offset address will be coming from any of the pointer registers, index registers, or base registers. So generally we have pointer registers like base pointer, stack pointer, and base register like BX register. And we have index registers also, source index and destination index. So all these registers, from any of these registers, offset address can be calculated. Now, we will see first what is meant by segment address and then what is meant by offset address. So here, based on the physical address only, the processor is going to fetch the instruction from the memory. That fetched instruction will be decoded and it will be executed. Now, coming to the segment address here, generally, the physical memory we have, that is 1 MB in 8086 microprocessor. That physical memory 1 MB has been divided into 16 logical segments. Each segment is of 64 KB. This segment address indicates the beginning address of any of the 64 kilobyte memory. Now, coming to the offset address represents the address anywhere in that 64 KB memory. Okay. So here offset address selects any location within the 64 kilobytes of memory segment. So with the help of this segment address and offset address, physical address will be calculated. But coming to here, the segment address is a 16-bit address, whereas the offset address is also 16-bit. But the address bus available in 8086 microprocessor is 20-bit address bus. So by considering this 16-bit segment address and offset address, it is necessary to develop 20-bit physical address. Now we will see what are different procedures that will help to calculate the physical address. That means in order to generate the 20-bit physical address by using these two 16-bit registers. Now, coming to here, we have one procedure. Okay, so that is here, the physical address is calculated by shifting the content of segment address. That means here we have to first consider the segment address, and that segment address we have to write in the form of binary. That binary data should be shifted 4 bits towards left, bitwise. Okay, so to that shifted data, we have to add the offset address. It leads to the 20-bit physical address. Now, so for example here, consider one example. So for example here, we have the segment address which is 1005H. Okay. So first you have to write this segment address in the form of binary. Okay. So if we write this in the form of binary, it will be 0001. That is for the value 1. And next for 0, it is 0000. And next another 0 is there. Write in the form of binary. And next value is 5. So the binary value of 5 is here 0101. So this is the binary value representation of the segment address. Okay. Next, this segment address should be shifted 4 bits towards left. So if the segment address is shifted 4 bits towards left. Okay. So how it will be means these 4 bits will be here. Okay. Next comes the next 4 bits. And next 4 bits are 0000. And next 4 bits are 0101. So if this data is shifted towards left by 4 bits, okay, at the LSB side, you will have 4 bits vacant. That 4 bits vacant bits will be filled with 0. Now, to this shifted data, segment data, we have to add the offset address. Okay. So for example, here, consider the offset address is 5555H. Okay. So we have to write this offset value first in the form of binary. Okay. So here the value of 5 in the form of binary is 0101. And next is again 5, again 0101. Next again 5, 0101. And next again it is 5. So it is 0101. Okay. So this is the offset address which we have written again in the form of binary. Now we have to add this segment address and offset address. That is the segment address which is being shifted towards left by 4 bits should be added with offset value. So if we add here, we will get 01 is 1, 0, 1, 0. And this 1 plus 1 is 1, 0, 1. And this is 1, 0. And here it is 1. And next 0 plus 1, 1. 0 plus 0 is 0. 0 plus 1 is 1. And this is 0. And next value 1, 0, 1, 0. And next 0, 0, 0, 1. Now we have to convert this value, binary value, into hexadecimal. If we see this binary value here, it will be 20 bit. Okay. So by using these two 16-bit registers, a 20-bit address is developed, which is called as physical address. Now we have to convert this binary value in the form of hexadecimal. So 0001 value in hexadecimal is 1. 0101, it is 5. So 0101, again it is 5. Next 1010. So generally here 1010 value is 10. But in hexadecimal, it is represented as A. And next is 0101. The value is here 5. Okay. So this 155A5. This is the physical address. So this is one procedure of calculating the physical address. And coming to the next procedure, there is another procedure also to calculate the physical address. Okay. So here, simply using the formula, physical address is equal to segment address into 10 plus offset address. So in the previous procedure, we have considered the segment address and shifted the data towards left by 4 bits. Okay. If you do like that, or just consider the segment address, make it into 10, both leads to same result. Okay. So here segment address into 10 plus offset address. So this is the formula we can use to calculate the physical address, 20-bit physical address. So here, why we are making that segment address shifted towards left by 4 bits, or why we are in this procedure, why we are making the segment address into 10 means, if we do like this only, the 20-bit physical address will be generated. If you are not doing this, again the physical address which it is going to give as a result is again 16-bit only. Since the address bus size is 20-bit, it is necessary to develop 20-bit physical address by using these 16-bit registers. So any of these procedures can be used. Okay. So here, if we use this procedure also, so consider the same segment address. Okay. So like the previous example. So here, for example, segment address is 1005H. Okay. So consider here the offset address. So offset address here is 5555H. Okay. So by using this formula, it can be calculated as segment address into 10 plus offset address. Okay. So segment address into 10 means 10050 and offset address is 5555. Add, then it is going to give the 20-bit result. Okay. So here 0 plus 5 is 5. 5 plus 5 is 10. But in hexadecimal it is A. Next 0 plus 5 is 5. 0 plus 5, 5. And next comes 1. Okay. So this is the another procedure to calculate the physical address. Okay. So this is the physical address. Okay. And it is 20-bit in size. So these are the two procedures to calculate the physical address. So any procedure can be considered to find the physical address value. Now, so here basically when the registers are given, we have to concentrate on the registers and then we need to consider what is the segment address and what is the offset address. Okay. So to find any physical address value, we have to see that if the value of IP, offset address, is given, compulsory, even though all the segment addresses are given, among them, we have to select this code segment address only to find the physical address. So in the same way here, for example, any of the offset addresses like stack pointer or base pointer is used in order to find the physical address. So compulsory we have to consider the segment as stack segment only. So we cannot go for code segment, data segment or extra segment. So based on the offset address handled by which register, we have to select the segment register. Okay. So but if we see here in the data segment and extra segment registers, offset registers will be same, which will handle the offset address. Like in this case also we have BX, DI and SI. In this case also we have BX, DI and SI. So for example, if the value of BX or DI or SI is given, okay, and if they give any of these, if all the segment registers are given and if the offset address is carried by any of these registers, even though all the segment registers are given, we have to select either data segment or extra segment. Okay, any of these should be selected. Especially, you have to consider this data segment only if it is given. If this data segment is not given, then we have to go for this extra segment to calculate the physical address. So here is one example. Okay, so here this is the given data. Here all the addresses are given. So here all the registers like AX, BX, SI, DI, all the registers whatever here given, they are of 16-bit registers. Okay, so that is why they will handle only 16-bit addresses. So here the addresses of all these registers are given. Now it is necessary to find the physical address. So generally in order to find the physical address, segment address and offset address is required. Okay, so segment address will be giving from any of the segment registers. Now if we consider here, we have code segment, data segment, and stack segment. 3 segment registers are there. Among these 3 segment registers, which segment register should be selected to give the segment address? Okay. So by default, if they are not specifying which segment should be used, by default you have to consider this data segment to have the segment address. And here the registers which will give the offset address means the registers like BX register. So BX is a base register which will give the offset address. And here this SI and DI, these two are the index registers. Index registers also represent the offset address. And here this BP, SP, these two are the pointer registers. One is base pointer, another one is stack pointer. Okay, so these two are the pointer registers which will give the offset address. So this base register, pointer registers, index registers will be giving the offset address. Okay. Now, so here, this is the example. Consider, for this example, how to calculate the physical address. Generally, we know here move AX, 5000H. So this 5000H is kept in the brackets. Okay. So this instruction will be coming under direct addressing mode. It comes under direct addressing mode. Why? Because the address is specified as a part of an instruction directly. Okay. So if the address is specified directly as a part of an instruction, especially what type of address is this means? It represents the offset address only. Okay. So indirectly in the instruction, offset address is given. In order to find the physical address, segment address is required. Okay. So they did not specify here which segment address should be used. So by default here, consider the data segment. Okay. So among these registers, the value of this data segment register here it is given. It is 1000H. Now, this is the data segment. Now, here the offset address is given in the instruction itself, and the offset address size is 16-bit. It is 5000H. Okay. So we have the formula in order to calculate the physical address. So the formula is here, segment address into 10 plus offset address. Okay. So segment address is 1000. So it is 1000 into 10. Segment address into 10. And the value is here 10,000 plus offset address. So here the offset address is 5000H. Now it should be added to the segment address. So the value of this is, so 0 plus 0, it is 0. 0 plus 0 is 0, again 0. Okay, so 0 plus 5, it is 5. And this 1, it is 1. Okay, so this is the physical address. So this is the value of physical address. And this is the hexadecimal value. And next, so considering the same given data, if you go for the next one, next instruction is given here, move AX, BX. So here BX is kept in the brackets. Okay, so register is specified here as a part of an instruction, but it is kept in the bracket. So what it represents here, this comes under register indirect addressing mode. Register indirect addressing mode it is. Why? Because register is specified as a part of an instruction, but it is specified indirectly. That means keeping it in the brackets. specifying some memory location. Okay. Now, here also the segment address, they did not give which segment address we have to consider. So, by default, you have to consider the segment address as data segment. Okay. So, considering here the data segment as the segment address. Okay. So, here segment address into 10 we have to do. So, first the segment address is 1000 into 10. If we do, this is 10000. Okay. And to this segment address, we have to add the offset address. So, here the offset address is getting from this register, which is BX. Now, so in this problem, we have the value of BX, which is showing the offset address. So, we have already told that base register can also give the offset address. So, here base register only has given and it is 2000H. So, to this segment address, we have to add the offset address. And here, we will have 0, 0, 0 and this is 2 and here 1. Okay. So, 12000H. This is the value of physical address. Okay. So, whatever the physical address size will be 20 bit. So, either this procedure can be followed or the first procedure like considering the segment address, shifting the bits towards left by 4 bits and then adding it to the offset address. That procedure also can be followed. So, any of the procedure gives the same result only. Now, so here for the same given data, but here the addressing mode is different. So, this is move AX, 5000 and here BX is also there. Okay. So, here this comes under register relative addressing mode. Register relative addressing mode. Okay. So, in this register relative addressing mode, so this is the relative which represents the displacement and this is the register. Okay. So, register relative addressing mode. Now, so here this entire thing will be giving the offset address. This entire thing will be giving the offset address. Now, if you see here, this is offset address is 5000. Generally, here given it is displacement and here the value of BX. If you consider here BX, so the value of BX in the given data, it is 2000H. Okay. So, if you add these two, 0, 0, 0, 7. Okay. So, this entire thing gives the offset address. And segment address we have to consider here is data segment address into 10. Okay. So, segment address into 10 means here the data segment, it is 1000H. So, it is 1000 into 10. It gives 10000. And for this, you have to add the offset address. Now, here the total offset address what we have got is 7000. This should be added here. Now, so here 0, 0, 0, 7, 1. This is the total physical address, which is of 20 bit in size. And next, so the same for the same given data, if this is the instruction, how to calculate the physical address. See here, as a part of an instruction, index register is there and also base register is there. Now, this instruction comes under based indexed, based index, addressing mode. So this comes under based index addressing mode. Okay. So now in order to calculate the physical address, segment address and offset address is required. So these two registers which are present as a part of an instruction, they will be giving the offset address. Okay. So here to get the offset address totally, we have BX. So the value of BX here, it is given as 2000, and here there is SI, and the value of SI is given, and the value of SI is here 3000H. Together here we have to add these two to form the total offset address. This is 0, 0, 0, and here it is 5. So this 5000 is the offset address. Now we have to consider this offset address to add with the segment address. So here the segment address is not given. So by default consider the data segment. Okay. And make it into 10. So here the data segment value is 1000H. So 1000 into 10. It leads to 10000. To this value the offset address should be added. Okay, so here the offset address value is 5000. So here this 5000 should be added. Okay, and it is going to give 00051. So this is the value of physical address, which is of 20 bit in size. So here it is hexadecimal. Next. So for the same thing here, the instruction is different. Okay. So here as a part of an instruction, we have index register, base register, and also displacement. Displacement is 5000. Okay. So it comes under relative because of this displacement, and because of this base register, based, relative based, and this is the index register, based indexed. So this is relative based indexed addressing mode. Now, so in order to find the physical address, so all these together gives the offset address. Okay. So first we have to find the offset address. So offset address is here 5000. Okay. And BX register. So the value of BX register is here 2000. And here the value of SI register, it is 3000. Okay. Now here if we add these three, it gives the total offset address. So it is 0, 0, 0, 5. This is 5 plus 2, 7, and 3, 10. So the 10 value in hexadecimal, it is A. Okay. So this is the total offset address. Now, to find the physical address, segment address into 10. Okay. So here the segment address, data segment is 1000 into 10. So it gives 10000. And here to this offset address should be added. So the value of offset address is this, that is A000. So by using this, we have to calculate the physical address. Okay. So here 0 plus 0 is 0, 0, 0, A, and it is 1. So sometimes the question will be like this, like the value of code segment register value is given, segment address is given, it is 40402. and the value of different offset addresses are given. So offset address we know it may be from base register or pointer register or index register. Okay. Now, so they are asking to calculate the effective address. It is nothing but the physical address. Okay. Here, one code segment register is given, but only one segment register is given, that is CS. Now, 3 offset addresses are given. So, among these 3, which should be selected? Which offset register should be selected? Okay. So, we have to go for register organization. So, we have seen if the segment register is this, from which register offset address should be considered. Or if the offset address is this, from which segment register we have to consider the segment address. Okay. So, since here code segment is given, we have to consider the IP as a offset address. Okay. So, here the code segment value is 4042 and the IP, that is instruction pointer which gives the offset address, its value is 0580. Now, so code segment address into 10. Okay. So 4042 into 10. So the value is here 40420. And for this, we have to add the offset address. And here the offset address is from the instruction pointer. So it is here 0580, 16-bit address. So 0580. So if we add this, it gives the physical address. Okay, or effective address. Now, so if we add these two, it is 0. Okay, and next 8 plus 2, 10. It is A, and this is 904. Okay, so here we should be careful while considering the register to find the offset address. So since this is code segment, we have to compulsory consider among these 3 instruction pointer only. So based on this, the given is code segment. That is why though the 3 index offset addresses are given, we have considered the instruction pointer register to find the offset address. Now, so here to find the physical address, if the question is like this, it represents one as segment address and another one as offset address. Like, for example, this is in the form CS IP. So this is also same in the form CS IP. So this represents the segment address and this 561E value represents the offset address. Now considering here the segment address into 10. Okay. So like 4370 into 10. It leads to 43700. To this data, the offset address should be added. Here the offset address value is 561E. Okay. So here 561E should be added. It gives the physical address. Okay. So 0 plus E, it is E. 0 plus 1 is 1 and 7 plus 6, it is 13. Okay. So the value of 13 in hexadecimal we have to write here. It is D. Next 3 plus 5, it is 8 and next 4. And for this example also here, segment address is 7A32 into 10. Segment address into 10. It leads to 7A320. To this, we have to add the offset address. So it is to 8. Okay, so the value what we are getting here is the physical address. Now, so this is 843A7. So in any example we see, whatever the physical address we are calculating, it will be compulsory 20 bit in size. So here it is hexadecimal, so we have to represent it as H. And so this is the next example here. So evaluate the physical address. So here also we need to calculate the physical address, but here they have given top of the stack. So here that means the stack related information will be given. So we have the segment registers related to stack, that is stack segment, and pointer register related to stack, that is stack pointer. So that is why here the stack segment value is given as 3000H and the stack pointer value is also given, that is 8434H. Now considering these two values only, we have to find the physical address which represents the address of the top of the stack. Okay. So here stack segment address is given. So it is 3000H. Okay. So we have to consider here stack pointer given. So here stack pointer address is 8434H. So considering these two, okay, so segment, stack segment address into 10. That means here 3000 into 10. It gives 30000 plus offset address. So offset address will be from the pointer register, that is 8434. So this segment address should be added with the offset address. So here it is 43483. Okay. So here H, this is the physical address. Physical address of the top of the stack. Now, so here again estimate the memory address of the next instruction executed by the microprocessor when operated in the real mode. So when the microprocessor is operating in the real mode, how the physical address will be generated means, just we have seen the procedure of calculating the physical address. Okay. So if the microprocessor is operating in the real mode, in the same procedure only, it is going to calculate the physical address, like considering the segment address, shifting the segment address 4 bits towards left. To that shifted data, offset address will be added. It is going to give the 20-bit physical address. So this is what happening when the microprocessor is operating in the real mode, physical address calculation. Okay. By considering that, we have to find the physical address by using these instructions. So here the first instruction is given, CS and IP, and second also the same CS and IP. Okay. So considering this here, segment address into 10. Okay. So it gives 10000, and here for this offset address should be added. So offset address will be here from the pointer register and the offset address is 2000H. Okay. So here this is 00021H. Okay. So this is the physical address. So in the same way here, this is segment address into 10. So it gives here 2000 into 10. Here it is 20000. And here the offset address is IP. It is 1000. So the same value should be added here, 000, and here it is getting the physical address. Okay, so here it is 00012. Now, so for the same, here using the same procedure, calculate the physical address of the following instructions. Okay, so here also the code segment value is given, data segment, stack segment and extra segment. These are the 4 segment registers given which are producing the segment address 16-bit. And here SI, DI index registers, that is BP, SP pointer registers, these will be giving the offset address. But here based on the instruction, we have to find the offset address by using that given data. Okay, so here in this example, this part of the instruction, if you see, they have given what is the segment address we have to consider and also the offset address we have to consider. So in this example, the segment address is ES. Okay, so in the given data, the value of extra segment is B000H. And here the offset value is getting from DI plus 5A. Okay, so here based on the given data, the value of DI is 6000. Okay, and the value of here 5A. Okay, so for this we have to add 5A. Now, the value what we are getting here is 605A. So what is this here? It is the offset value we have to use. Okay, so we have the formula for this also, segment address into 10 plus offset address. Okay, so it will give the physical address value. And so from this here, the segment address into 10, if you do B000 into 10 plus the offset address value is 605A. Okay, so if we add these two, we will get the value B605AH. So this is the physical address for this instruction, because here they have specified clearly the extra segment is the segment value address. Now, for the same data here, the second example is given, that is IMUL, which represents signed multiplication, and here AX, and this part of the instruction here, this entirely will give the offset address. Okay, so now first we will find the offset address, that is first SI plus BX minus 8C will give the offset address. Here the value of SI is given, so it is 2000H. We have to consider that value, and the value of BX is given, so it is 5200H. We have to consider that. Okay, so SI is here 2000. So to this we have to add BX. So BX is 5200. Okay, to this. Now, so 0027. Again for this you have to make minus 8C. So this is minus 8C. So if you are performing the subtraction operation, here you will get 4, 7, 1, 7. Okay, so this value gives the offset value. Now, considering this, we have to find the physical address. That means segment address into 10. Okay, so here the segment address is not given. So by default, we have to consider the data segment as the segment address. Okay, so here 8000 into 10. It gives 8 0000. So for this, we have to add this offset value. So the offset value is 7174. So if we add these two, here it is 47178. Okay. So this is the value of physical address. Now, so the next instruction is here, push AX. So out of all the segment and offset registers, since the instruction is here push, we have to use the stack related information. So we have to consider here stack segment and stack pointer register. Okay, so the stack segment will give the segment address and the stack pointer will give the offset address. So here this stack segment, so here the stack segment value in the given data, it is represented as A000H. So it is A000H, whereas here the stack pointer value, here it is 0002H. 0002H. Now we have to consider only these two registers to find the physical address out of all the given data. Okay. So here segment address into 10. So the segment address into 10 means A000 into 10. So it gives A0000 plus offset address. So here offset address is from stack pointer. So here the stack pointer is 0002. And if we add these two, we will get here, this is 2000 and here it is A. So this is the value of physical address. Now, and here there is one more example. Okay. So to this instruction and AH, SI plus 42. Okay. So this SI plus 42 together will gives the offset address. Okay. Now here the value of SI is given. So here if you see the given data, the value of SI, it is 2000H. Okay. So here the value of SI is 2000H. To this we have to add 42. So it is going to give 2402. So this is the value of offset address. Okay. And next, coming to the segment address, here they did not give which segment address we have to consider, but by default here we have to consider the data segment if it is not given. So here data segment into 10. Okay. So data segment into 10 means data segment is 8000 into 10. So it gives the value 80000. And for this we have to add the offset address. Okay. So here offset address totally we got 2042. Now, so if we add these two here, 24028. Okay. So this is the value of physical address. Now, so this is the simple instruction as we know. So this SI is a part of an instruction which will give the offset address. Okay. So here the segment, what we have to consider is data segment. So here segment address into 10. So here the data segment value is 8000. So here 8000 into 10. So it is giving 80000 plus offset address. So as a part of an instruction, there is a index register which gives the offset address. And the value of this index register SI, it is given 2000 H. So this 2000 H, it should be added. So it is 00028. So this is the physical address. So here calculation of physical address. So in this way we have to find the physical address of an instruction. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.